Alright class, this is the first lesson of the Unit 3. We are going to be simplifying algebraic fractions. You guys did this when you were learning about fractions way back when. To simplify, all you have to do is cancel out the common factors. But that means that you have to be able to factor it, okay? So for example, I know 27 is 3 times 3 times 3, or 3 times 9, and I know 18 is 2 times 9. So since we both have a 9 on top and bottom, and there's a multiplication sign, you can cancel them. Here's what you cannot do. You cannot, if it's a plus sign, cancel the 9s. That is one of the most common errors in mathematics. Okay? Because right now this is the fraction 12 over 11. And if you cancel the 9s, you turn it into the fraction 3/2. Those are not the same. You shouldn't be changing those. So with a plus sign, anything with a plus sign should be in its own grouping. So anyway, we'll deal with that later. So we do the same thing with algebraic fractions. So it says simplify these fractions and state the domain restrictions. Let's simplify these first. And when they say simplify, basically they mean factor first. So all these, again, our favorite thing to do is coming back. A lot of these, though, will be either guess and check or just standard factoring. So two numbers that multiply to 20 are 10 and 2 or 4 and 5, but we need to add to 12. So I'm going to do 10 and 2. And then the bottom is x squared plus 7x plus 10, and that would be 5 and 2. Now, because these are pieces that are factored out and they are being multiplied in between them, you can cancel the chunks or the piece as long as there's another piece to cancel with. Now, before we do that, we need to look at what this problem can't have for x. Domain restriction. It's basically the number that makes the function undefined, which means look for numbers that make the denominator equal to 0, because you cannot have a 0 on the denominator. Where to find it? Look at the unsimplified denominator. So before you simplify it, but you need to factor it, okay? So right now is where we would look and see what can't we have. Now you get two kinds of domain restrictions. You can have an asymptote. That means that it's an invisible line that the graph kind of doesn't cross because it doesn't exist there. Or you can have a hole where a part of the graph is removed. We're going to talk about those in the next video. For right now, all I want to know is what are the values that you cannot have. Well, once you simplify it, without actually canceling though, you set both pieces equal to 0 because we can't have 0 on the bottom. So what are the values that we can't have? We can't have -5 or -2. So we would say that our domain, and this is the way I want you to write it, are the x values such that x cannot equal -5 or -2. Okay? And since we're doing this all over real numbers, we don't have to state that it's real numbers other than that. And finally, the simplified form is we can cancel out these pieces, which we'll find out later is a whole. Again, can't cancel out the x's, can't cancel 10 divided by 5. That's a plus sign there. Those are numbers themselves. Okay? If it was 5 times x and 10 times x, then you would be correct. But it's not, so don't cancel there. Alright, let's keep going. So again, factor first. What is that? 4 and 1. This one is a difference of squares. So if you set both of these pieces equal to 0 on the bottom, our domain restriction is going to be that x cannot equal. The opposite of that is +4, and the opposite of that is -4. So if we have a positive or -4 in the problem, the fraction's undefined. Now we simplify the pieces that cancel. It would be these two. So my simplified version of this factor, or of this fraction I should say, is x plus 1 over x minus 4. Now, number 3 is a little different. First of all, the bottom we can already state what the domain is. The domain is that x cannot be 5, because that will make the bottom 0. But since there's already it's already factored on the bottom, we're good. We have to factor the top. However, here's one thing you have to note. when the x piece is negative, you want to factor out a negative first. So I'm taking the negative out of the top piece, and that changes this around. So when you factor the negative out, this makes the 25 negative and the x squared positive, which is nice because now we can factor this and say that we have a negative, and then we have x minus 5 and x plus 5. So we have something that matches. And now we can simplify. And you don't have to redistribute the negative. You can leave it in factored form. So we have a negative, and then what's left, we just have an x plus 5. Okay, so these are all my solutions, and these are my domain restrictions. Okay. All right, we got two more. This one's a little bit more intense. We're stepping up the difficulty now that you know what we need to do. We need to factor this. This is going to be seeing what you remember from factoring. Again, the bottom, I'm going to kind of do these separately. So I'm going to rewrite this so it's in descending order. The top, I'm going to start by grouping because it looks like this is grouping, right? There's 4 pieces. Let's see if that works. So on the top, I'm going to pull out an x squared, and I'm left with an x minus 2. And if I pull a negative 9 out, I'm left with an x minus 2. Okay. So the next step is to rewrite the top. And the bottom, we want to take a GCF out. Well, we can take a 2 and an x out. And when we do that, we're left with x to the 4th minus 7x squared plus 12. Okay. Next step is we factor the top and the bottom. Some more. We can factor the x squared minus 9 to be x plus 3, x minus 3, x minus 2 is still there. The bottom has the 2x, and then this is an x squared, and it's what, 2 numbers that multiply to 12 that add to negative 7 minus 4 minus 3. So my final step is I get down to complete factored form, which is x plus 3, x minus 3, x minus 2, all over 2x, x plus 2 and x minus 2, because I have to factor that, and then this one's not factorable. Alright, so before you cancel, we need to find the domain restriction. So we have to set each piece equal to 0. So right away I'll do that over here. My domain is x such that x cannot equal, when you set 2x equal to 0, that's just 0. We get a negative 2 and a positive 2. But we have we have this piece here. So we have to kind of figure out what that is. So we'd set that piece equal to 0, move the 3 over, and take the square root. And remember your plus or minus. So that means that x can also not be plus or minus root 3. So we have 5 domain restrictions for that. Okay? So there's the answer for the domain restriction. And then the last step, cancel out everything that cancels. The 2 and the x don't have a 2 or an x that's by itself, so we're good there. We just have the minus 2's, it looks like. Everything else can't cancel. This doesn't factor into that, so we're good. So my final answer is x plus 3, x minus 3 on top, over 2x times an x plus 2 times an x squared minus 3. Alright, one more to go. Again, you want to maybe rearrange, and you want the highest number first. So since again we have a negative x to the 4th and a negative x cubed, I'm going to start by taking a negative out of both, and you could actually cancel those if you want. So we have 3x to the 4th minus 24x. And if I take a negative out of the bottom, I get x cubed plus 2x squared plus 4x. Right away, because negatives don't affect the domain, I'm going to cancel these right now, just because we factored a negative out of both of them. So now I'm going to factor the top. First thing you should do is GCF. So I get a 3x, and I'm left with an x cubed minus 8. And the bottom I factor, and I pull a GCF out, which is just an x, and then you get an x squared plus 2x plus 4. Okay, you can't factor that. 2 numbers that multiply to 4 that add to 2, can't factor that. So the bottom is factored. But hopefully you guys remember this pattern. We just did it. That's the difference of cubes. That's the a minus b, a squared plus ab plus b squared, where a is equal to x and b is equal to 2. So, let's do that. So we get x minus 2, x squared, plus 2 times x, which is 2x, plus 2 squared, which is 4. And sure enough, you should see that that piece matches the piece on the bottom. So those will be able to actually cancel, which is kind of nice. Now before we cancel anything though, remember we need our domain restrictions. Here's what I want to talk about though with domain restrictions. We'd set that equal to 0, so x equals 0. And when we set that equal to 0, we have to do quadratic formula. But here's what I want to show you. This number in here is 4 minus 16. So since this is imaginary, we don't list it in our domain restrictions, because our domain we are dealing with here is only real numbers. So that means that the only value that x cannot be for this problem is it cannot be 0. You don't have to worry about that piece there before you cancel it out. Okay, so now you look at individual pieces. Remember, you can think of this as a 3 times an x, and that's an x. So because there are x's that were factored out, they can go away, and then this big piece can go away, and then you just end up with that this simplifies to 3 and an x minus 2. And that's it. There's our domain. Okay, so that is simplifying and canceling, and also domain restrictions. All right, good job.